Friends, today I want to simplify this radical expression. To do that, you can maybe remember when you have a radical expression in denominator, the best way to simplify is to multiply that expression to the conjugate of denominator. So I can write it again, 4 minus the square root of 15, again the same main equation, times the conjugate of the denominator. The conjugate is 4 plus 15 and 4 plus the square root of 15. And that is, now I can write denominator 16 times a parenthesis 4 plus 15 over denominator. Denominator is 4 minus a square root of 15 times 4 plus a square root of 15. And you can maybe remember an identity like a minus b times a plus b, which is a squared minus b squared. That is very helpful identity. You can use it always in the conjugate multiplication. Now here, if you use that identity, then the first term is a square minus the second term is a square. And the answer is, again, 16 should be multiplied to the both terms in the parentheses, which is 16 times 4 is 64 plus 16 times 15 over 4 squared is 16 minus, and this term could be simplified, minus 15. And you can see it's very simple, 16 minus 15, which is just 1. And you can ignore this denominator in the next step. So I can write it, simplified expression 64 plus 16 times the square root of 15 over 1, which I ignore that. It doesn't matter to write it or not. But you can go further. You can go further or not. We can try. But you can remember another identity which is very helpful here. We can use it. It's a binomial squared identity when a plus b is squared equals to the first one squared, second one squared plus 2 times a b. We can use this identity or any identity you maybe prefer. If you watch my videos in my channel, you can find a lot of examples. I use these identities or another ones to a lot of examples I solve in my channel. Maybe you can subscribe there and leave your comment or your opinion there. You're welcome to leave your message. We can make a video in your ways. But in my way, now I can try this identity here. To find out it's suitable or not, we can write this expression as 64 plus, because I want to try to make the same expression with this identity and our expression. 2 times 16 is 2 times 8 times the square root of 15. Now I can the same expression like it here, but it leads to this expression or not. We can try it. Now My first guess is this one is A and this one is B. We can try it's suitable or not. I mean, A is 8 and B is square root of 15. Now, if it's suitable or fit this identity, should be both sides are same with this expression. But how? I can show you. A plus B square root squared is exactly, I can write just the numbers here. A is 8 plus square root of 15 to a square, which is based on this identity. 8 to the power of 2 is 64. You can see it's exactly 64 here. Plus the second one squared plus 2 times 8 times square root of 15, which is equals to 64, and this one simplified 15 plus 16 times square root of 15. If you compare these two expressions, you can see 64 is here, 16 square root of 15 is here, but this 15 is extra. So they are not fit exactly each other. So maybe the first guess here is not correct. You can go further, further with this guess, but you won't be able to simplify that. Therefore, maybe this guess is not correct. I can try another guess. I erase this way and find another way to simplify that. Again, we have 64 plus 2 times 8 times square root of 15. Maybe I can take this 8 under this radical expression. And you know, when it goes under that, 8 will be 8 squared. So 64 plus 2 times, I will take this 8 to under a square, which is 8 squared, but I can write it 8 times 8, same. And 15, I can write it breakdown, maybe I can find another pair. 3 times 5. 3 times 5. And by multiply these numbers each other, I can find another pair. 64 plus 2 times, I can multiply this 8 with this 5 and this 8 with this 3. It's the only way we have now. 8 times 5 is 40 times 24. Okay, I can go further with this expression. I erase this side because I don't need any more than. And I go further with this new format. Maybe it's correct, maybe not. We don't know. We just try it. Now it equals to 64 plus 2, and I can break down this to radical expression, 40 times 24. Okay, now I have another pair here. I can let A as square root of 40 and B as square root of 24. Okay, I can go further with this pair. Maybe they are the correct pair or not. We don't know even now, but we can try it. If it's the answer, so it's answer. If it's not, okay, we can't maybe simplify this radical expression. Now, I can go try this pair with this identity. A plus b squared. It means 40, the square root of 40 plus the square root of 24 squared, which is the first one squared second one squared and 2 times 40 times 24. And you can see this one is 40 plus this one, because this 2 and this 2 is simplified, 24 plus 2 times this one, 40 times 24. And you can see 40 plus 24 is 64 plus 2 times 40 times 24. So we have exactly this expression here. So this pair is exactly fits with our main expression here, and I can see that is our answer. I can erase it and write it like with this pair. So we confirm that. We confirm that they can be the answer. So this one is exactly, you can see this expression is exactly this binomial expression. So with this A and this B, 40 plus 24 to the power of 2. Now I can simplify this power with this square root. So the answer is square root of 40 plus square root of 24. But maybe I can go further with this expression. I can erase here and go further with these numbers. How? Square root of 40, I write it again here, 24. And you know that one is 4 times or 4 times 10 plus 4 or 4 times 6, and that is 2 times square root of 10 plus 2 square root of 6. Now I can write it 2 square root of 10 plus square root of 6. It's the simplest form we can find out from this main expression here. Maybe you can simplify it more. Please write it for me in this video. Thank you for your attention.